Welcome back. We are the release. We are the reducing unit now. Mind you, we are the reducing unit now. So at the reducing unit, we have ketoacyl reductase, dehydratase, enoyl reductase. These are the three enzymes there. Those are the three enzymes there. So now remember the last time we stopped at um beta ketoacyl ACP, right? That was where we stopped. So now the coenzyme needed for synthesis that help in reducing the intermediates of synthesis is actually NADPH. Yes, while in that of catabolism, that's breakdown, we use NADH. Yes, we use NADH. So now the the enzyme here is NADPH dependent. So now look at how it carries out its actions here. We take two hydrogen. Remember this is the beta. This is the beta. The beta carbon. So now, since this is the beta carbon now, what we'll do here is this is the alpha and this is the beta. So what we'll do here now, we'll take the whole of this as if it's a functional group. So we just take alpha and beta. So now, what this enzyme does is that it will introduce hydrogen to this beta carbon, to hydrogen. So that's two atoms of hydrogen. So now, remember this how this guy the ketone group is there. So it's bonded to this methyl group and the rest of the structure here. The rest of the structure here. This as acyl. Let's take it as still let's call it as acetyl ACP because look at this two carbon unit. So let's call it as acetyl ACP. So it's bonded to them. Look at the bond here, right? So now, if you check the bond now, you see that it's 1, 2, 3, 4. It's complete, right? So now, since it's complete, what this hydrogen here, hydrogen will do, let's take this hydrogen first. So if it comes here, it will disturb, let's see, let me draw this oxygen well. So this oxygen is connected like this. So ignore this one, ignore this one, ignore this one. So now since it's connected like this through this bond, so if this hydrogen comes in, it will take this electron. Remember this electron here is still bonded to this. So now, but there's a free electron here now. So that means another hydrogen has to come here and bind to this. So that it will be complete. So that means you have OH and H. So that's why you see beta hydroxybutyryl ACP. Butyryl 1, 2, 3, 4. 1, 2, 3, 4. 4 carbon. So you have butyryl ACP, beta hydroxybutyryl ACP. So that's how the ketoacyl reductase perform its function. So we'll move to the next step. This is step 4. So we move to step 5. So this is step 5. Step 5 is catalyzed by dehydratase. From the name, my man here, what he does is it dehydrates. It's like the sun. Perform the function of the sun. It comes with high temperature and pulls out water. He's very angry. He's deadly, very deadly. So what he does is he pulls out water from here. He pulls out water from this beta. He pulls out water from this beta carbon and the alpha carbon. He removes the OH here and removes the hydrogen here. So that's what he does. He pulls out water from here, beta carbon, hydrogen from the alpha. Takes hydroxy group from the beta carbon and takes hydrogen group from the alpha carbon. So that's what he does. That's what it does. So it now creates a double bond between the alpha and the beta carbon. So that's what the rest does. So now, if you look at it, remember the hydroxy group actually bind to one electron, like right? So now, let's remove the hydroxy group. We now remove the hydrogen. So we have hydrogen, hydroxyl. So if you add them together, what do you get? You get water. So now, And what happens? You have generating an extra bond. So that's the extra bond here. So you now have CH, CH, you now have bond between. So you now have what we call enoyl ACP. So now, since this is enoyl ACP or generated enoyl ACP, we'll take it to who? Enoyl reductase. Enoyl reductase. Take it to enoyl reductase. He's annoyed. Enoyl. Enoyl is angry. So enoyl is annoyed. So we'll take it to him. We'll say, enoyl, please reduce us. So enoyl will be like, okay, this is my job. I'm going to do it. This is step 6. I'll call this enoyl reductase. So enoyl reductase will be like, okay, I'm NADH, NADPH dependent. So I'm capable of performing this function. So what I'm going to do is I'll introduce 2 hydrogen to you. I'll bless you with 2 hydrogen. You just give him 1, 2 hydrogen, and break the pi bond. So to break this bond up here, to break this pi bond there, and everything will be restored. 1, 2. Remember, we actually remove OH, and remember OH was binding to 1 electron. Actually, with hydrogen was binding to 1 electron. So it was this two free electron that came together to form another bond again, an extra bond, which is pi bond. So now, if we introduce hydrogen electron again to bind to those 2 electrons, so you have nothing. You just have you have just 1 bond, which is what you're seeing here. So everything is normal. So now butyryl ACP, 4 carbon. So now the next unit is the releasing unit. So go to the releasing unit. So we are done with the reducing unit now. These are the actions of the reducing unit enzymes. These are they perform their actions. So we are done with the releasing unit. So next video we'll go to the releasing unit. Sorry, I'm stammering, but that's how I am. I don't know. So now we'll go to the releasing unit in the next video. So I just hope you all love this. So now I think we are done. We're done for today. I'm just so tired. We're done. So thanks for watching. Please subscribe and turn on the notification bell. Thank you, and God bless you.